In the last module, we set up the infrastructure for our Angular application. Now we are ready to build our first component. Welcome back to Angular 2 Getting Started from Pluralsight. My name is Deborah Kurata, and in this module we walk through building a very basic component, with a focus on clearly defining the component's parts, their meaning, and their purpose. We can think of our Angular application as a set of components. We create each component, then arrange them to form our application. If all goes well, those components work together in harmony to provide the user with a great experience. In this module, we take a closer look at what an Angular component is and examine the code we need to build one. We walk through how to create the component's class and how and why we need to define metadata. We look at how to import what we need from external modules, and we discover how to bootstrap the component we've built to bring our application to life. At this point, we'll have the world's simplest working Angular application. We'll continue to add to this application throughout this course. Looking again at the application architecture that we defined in the first module, we currently have the index.html file in place. In this module, we'll build the app component. Let's get started. An Angular component includes a template, which lays out the user interface fragment defining a view for the application. It is created with HTML and defines what is rendered on the page. We use Angular binding and directives in the HTML to power up the view. We'll cover binding and directives in a later module. Add to that a class for the code associated with the view. The class is created with TypeScript. The class contains the properties or data elements available for use in the view. For example, if we want to display a title in the view, we define a class property for that title. The class also contains methods, which are the functions for the logic needed by the view. For example, if we want to show and hide an image, we'd write the logic in a class method. A component also has metadata, which provides additional information about the component to Angular. It is this metadata that defines this class as an Angular component. The metadata is defined with a decorator. A decorator is a function that adds metadata to a class, its members, or its method arguments. So a component is a view defined in a template, its associated code defined with a class, and metadata defined with a decorator. Want to see what a component looks like in TypeScript? Here is a simple component. It might look complex at first, so let's break this component into chunks, starting at the bottom. Here is our class. It defines the properties and methods needed by our view. Here is the component decorator that defines the metadata. The metadata includes the template that lays out the view managed by this component. And here we import the members that we need. Let's examine each of these chunks in more detail, starting at the bottom with the class. If you have done any object-oriented programming in languages such as C#, VB.NET, Java, or C++, this code should look familiar. A class is a construct that allows us to create a type with properties that define the data elements and methods that provide functionality. We define a class using the class keyword, followed by the class name. A common Angular convention is to name each component class with the feature name, then append the word component as the suffix. Also by convention, the root component for an application is called app component, as shown here. This class name is used as the component name when the component is referenced in code. The export keyword here at the front exports this class, thereby making it available for use by other components of the application. And as we learned in the last course module, since this file exports something, this file is now an ES module and will be loaded by our module loader. No need to add a script tag for it. Within the body of the class are the properties and methods. In this example, we only have one property and no methods. A property defines a data element associated with the class. We start with the property name, which by convention is a noun describing the data element, and it is in camel case, whereby the first letter of the name is lowercase. In this example, it is the title of the page. Using TypeScript's strong typing, we follow the property name with a colon and its data type. In this example, the page title property is a string. We can optionally assign a default value to the property as shown in this example. Methods are normally defined within the class body after all of the properties. Method names are often verbs that describe the action the method performs. Method names are also in camel case, whereby the first letter of the name is lowercase. So that's it for the class. But a class alone is not enough to define a component. We need to define the template associated with this component class. How do we provide this extra information to Angular? With metadata. Let's look at that next. A class becomes an Angular component when we give it component metadata. Angular needs that metadata to understand how to instantiate the component, construct the view, and interact with the component. We define a component's metadata with the Angular component function. In TypeScript, we attach that function to the class as a decorator. A decorator is a function that adds metadata to a class, its members, or its method arguments. A decorator is a JavaScript language feature that is implemented in TypeScript and proposed for ES 2016. The scope of the decorator is limited to the feature that it decorates. A decorator is always prefixed with an @ sign. Angular has several built-in decorators we use to provide additional information to Angular. We can also build our own decorators, but that is out of the scope of this course. We apply a decorator by positioning it immediately in front of the feature we are decorating. When decorating a class, as in this example, we define the decorator immediately above the class signature. Notice that there is no semicolon here. This syntax is similar to attributes used in other programming languages. We use the @component decorator to identify the class as a component. Since the decorator is a function, we always add parentheses. We pass an object to the component function as indicated with the curly braces. The object we pass in has many properties. We are only using 2 of them here. If we plan to reference the component in any HTML, we specify a selector. The selector defines the component's directive name. A directive is simply a custom HTML tag. Whenever this directive is used in the HTML, Angular renders this component's template. We'll see how this works in the upcoming demo. A component should always have a template. Here we define the layout for the user interface fragment, or view, managed by this component. The double curly braces indicate data binding. We bind the h1 element value to the page title property of the class. So when this HTML is rendered, the h1 element displays Acme Product Management. We'll see that in the upcoming demo as well, and we'll cover more about binding in a later module. There is one more key task before our component is complete: importing. Before we can use an external function or class, we need to tell the module loader where to find it. We do that with an import statement. The import statement is part of ES 2015 and implemented in TypeScript. It is conceptually similar to the import statement in Java or the C# using statement. The import statement allows us to use exported members from external modules. Remember how we just exported our class using the export keyword? That means that other modules in our application can import our exported class if needed. We'll use the import statement throughout our code to import any third-party library, any of our own modules, or from Angular itself. We can import from Angular because Angular is modular. It is a collection of library modules. Each library is itself a module made up of several related feature modules. When we need something from Angular, we import it from an Angular library module, just like we import from any other external module. Use this link if you want to view the list of available Angular 2 library packages and their current versions. In our component code, we use the component decorator function from Angular to define our class as a component. We need to tell the module loader where to find this function, so we add an import statement and import component from Angular core, like this. We start with the import keyword. We identify the name of the member we need within curly braces. In this case, we need the component decorator function. And we define the path to the module containing that member, in this case the Angular core library module. If we need multiple members from the same module, we can list them all in the imports list, separated by commas. We'll see examples of that later in this course. So this is a component. Now we're ready to build the first component for our sample application. Let's jump in. In this demo, we build our app component, which is the root of our application. Here we are in the editor with the APM folder open. This is the folder we set up in the last module from the starter files I provided. Let's open the app folder. I provided the app component as part of the starter files so that we could run the application right away. I named the file app.component.ts. The file naming convention that will follow throughout this course is to start with the feature name. This is our root application component, so by convention it is called app, then a dot, then the type of ES module defined in this file, in this case component, to identify this ES module as a component, another dot, and the extension. Since we are using TypeScript, we'll use TS as the extension. In VS Code, I can click the Explorer icon to close the Explorer and see more of the code. I can reopen the Explorer by clicking the icon again. Now I'll delete the starter code for this file so we can build the app component from scratch. I like to start coding by building the class, but the order of these steps really don't matter. When we build a class, we first type in the export keyword to ensure that other parts of the application can use this class. Next, we type in the class keyword, then the name of the class. Since this is our application component class, we'll follow conventions and name it app component. Inside this class, we'll define one property, the page title. We type the property name, followed by a colon, and the property data type, which for the page title is a string. Notice how IntelliSense helps us here. For this property, we want to define a default value for the page title. Next, we define the component decorator above the class. The component decorator always begins with an @, then the name of the decorator, and we're using the component decorator. The component decorator is a function, so we type parentheses. And we're going to pass in an object, so we type in curly braces. Notice how TypeScript has underlined the component decorator and flagged it as an error. The error is can't find name component. Any guesses on what the problem is? If you said that we are missing the import statement, you are right. We need to import the component decorator from Angular core. Now the error underline goes away and we can complete the metadata. In the component metadata, we specify a selector for the name of this component when used as a directive in the HTML. Now that we've imported the appropriate module, we get IntelliSense for these properties. We set the selector to PM-app. The current convention is to prefix each selector with something to identify it as part of our application. So we selected PM for product management. The second part of the name represents the component, so we used app since this is our app component. Next, we define the template. To specify another property here, we enter a comma and then the name of the other property. We want to define template. Any valid HTML can be specified in the template. We'll dive deeper into templates in a later module. So for this example, I'll just paste in the HTML. And we're done. We have now created the first component for our application. Yay! But how do we use it? How do we display its template? Have you heard the saying, pulling yourself up by your bootstraps? Originally meaning to improve your situation by your own efforts, in tech it has come to mean a self-starting process that loads and goes. We need to tell Angular to load our root component through a process that's called bootstrapping. And we need to set up the index.html file to host our application. Let's look at both of these steps. Most Angular applications have an index.html file that contains the main page for the application. This index.html file is often the one true web page of the application. Hence, an application is often called a single-page application, or SPA. But don't worry, it will look to the user like we have lots of pages, as we saw in the demo at the beginning of this course. What we do is insert bits of HTML into the one HTML page defined in index.html. Let's see how that works. Here again is our app component, just shifted to the right. Recall that the selector is the name of the component when we use it as a directive in HTML, and the template defines the HTML that we want to display. So in the index.html file, we simply add the selector where we want our template displayed. Here in the template, we call this a directive. A directive is basically a custom element. When the root element is loaded, the loading app message appears. As soon as the loading is complete, the HTML defined in the component template is inserted between the selector element tags and appears on the page. Let's go through the Angular application startup process in detail. I've already set this process up for our sample application, but it's useful to know how it works as you start to build your own applications. We have the index.html file set up to host the application by specifying the selector from the root application component as a directive in the body tag. But how does the module loader find our root application component? Recall from the last course module that we configured System.js, our module loader, in index.html to start up the application by importing an ES module from the app folder. And we saw that the System.js configuration file defined the main entry point of the application as main. So main is the first ES module loaded for our application, and it looks like this. The main TS file bootstraps our first Angular module, providing a starting point to kick off our application. For this sample application, we want the Angular compile to compile the application in the browser dynamically and then launch the application. So we begin by importing Platform Browser Dynamic. Other bootstrapping options are covered in the Angular 2 Setup Revisited module later in this course. Here we specify where the module loader can find our Angular application module by adding an import statement to import app module. Then we call a function that bootstraps our first Angular module. Once we've bootstrapped our Angular application, we can leave the main.ts file and never look upon it again. Here is our application's Angular module. We talked about Angular modules in the last course module. Angular modules help us organize our application into cohesive blocks of functionality and provide boundaries within our application. We define an Angular module with a class. We identify the class as an Angular module by attaching the ng module decorator and passing in metadata defining the details of this Angular module, and importing what we need. In the declarations array, we define which of our components belong to this module. By convention, our main application component, app component, belongs to the application's Angular module, app module, so we declare it here. We can add other components here as well. We'll cover best practices for organizing our application into Angular modules later in this course. In the imports array, we define the external modules that we want to have available to all of the components that belong to this Angular module. External modules could be modules provided by Angular, a third party, or our own Angular modules. Here we import Browser module, which every browser application must import. Browser module registers important application service providers, such as error handling. The Bootstrap array defines the root component of the application, which is our app component. The root component should contain the selector we use in the index.html file, which it does. When this component is loaded, the template defined here appears within the directive tags, and the user sees the user interface for our component. So, index.html loads and executes the ES6 module main. Main bootstraps the application's Angular module, app module, which in turn bootstraps the root application component, app component, and the component's template appears in the browser. Luckily, we only need to set up the bootstrapping process once. Now let's see this bootstrapping process in action. In this demo, we'll set up index.html to host our application and bootstrap the app component to bring our application to life. Here we are, back with our sample application exactly how we left it. Let's open the index.html file. To host our application, we use the component selector as a directive here within the body element. We can think of a directive as simply a custom HTML tag. Now let's delete our extra text here. And if we want to display a message on the page while the application is loading, we add that text between the component tags. The bootstrapping code we discussed in the slides is already in place. So index.html loads and executes the ES module main. Main bootstraps the application's Angular module, app module, which in turn bootstraps the root application component, app component. Now we're ready to run. We saw in the last module how to start the application by typing npm start in a terminal or command window. We'll first see the original loading app message. And when the root component is loaded, that message is replaced with the HTML from our component, and the binding in that HTML is replaced with the value of our page title property. We now have a working, albeit very small, application. And since the npm start command set up the TypeScript compiler to watch for changes, we can make a change to the code and immediately see the results in the browser. Cool. Before closing the browser, let's take a moment and look at the browser developer tools. With the browser window active, press F12. The exact tools you see here depend on the browser you are using. I'm using Chrome. Most modern browsers provide a console tab as part of the development tools. This is always the first place to look if the page does not appear as expected, or doesn't appear at all. Errors, warnings, and other information is displayed here. Use the Elements tab or DOM Explorer to view the HTML displayed in the page. This is a depiction of the DOM or Document Object Model. The Document Object Model is a document model loaded into the browser and represents our HTML as a node tree, where each node is a part of our HTML. Here is the HTML from the index.html file, and here is our selector tag. Open the selector tag, and we see the HTML that we defined in our components template. This view is a great way to see the HTML for the rendered page. There is also a debugger option available here on the Sources tab to view and debug our code. Now let's finish up this module with some checklists we can use as we build our own components. Angular is all about components, so our first set of checklists are for building a component. We create a class for the component with code to support the view. We use a decorator to define the component metadata, which includes the HTML for the component's template. And we import what we need from any third-party library, from our modules, or from Angular itself. When creating the component class, we give it a clear name. This is not only the name of the class, but the name of the component as well. Be sure to watch the casing since JavaScript is case-sensitive. By convention, use Pascal casing, whereby every word of the name is capitalized. It is common to append component to the end of the class name to make it clear that it is a component class. Be sure to include the export keyword on the class signature. Recall what the export keyword does? It makes the class accessible to be imported by other parts of the application. If the component view displays data, such as a title, the data element is defined as a property of the class. To leverage TypeScript's strong typing, be sure to set the appropriate data type for each property and set a default value where appropriate. Use camel case for property names with the first letter lowercase. If the component view has functionality, such as hiding and showing an image, the logic is defined as methods in the class. Use camel case for method names with the first letter lowercase. How do we define the metadata for our component? If you said a component decorator, you are right. A class is not a component unless it has a component decorator. Be sure to prefix the decorator with an @ Since a decorator is a function, add parentheses and pass in the appropriate object properties. Use the selector property to define the name of the component when used as a directive in HTML. Be sure to prefix the selector for clarity. Note that the selector property is not needed if the component is not used in any HTML, as we'll see later in this course. Use the template property in the component metadata to define the view's HTML. Since we define the HTML in a string literal, we often get no IntelliSense or syntax checking, so take care to define correct HTML syntax. We'll see alternate ways to create the template for a component in the next module. So why do we need to use import? The import statement tells Angular where to find the members that this component needs from any external modules. The import statement requires the import keyword, followed by the member name and module path. Take care when defining the member name as it is case sensitive. The path to the module file must be enclosed in quotes and is also case sensitive. And remember that we don't need to specify the file extension. So, what do you do if you followed the steps, but the sample application doesn't work for you? You follow the something's wrong checklist. First, press the F12 key in the browser to view the developer tools and check the console. The Angular error messages are often quite clear if you read past the initial line of technical details. Second, recheck your code. For any HTML, be sure the tags are all correctly closed, and that all of the Angular directives are correctly spelled and cased. Angular directives are case sensitive. For the TypeScript code, be sure the braces are all properly closed. And just like JavaScript, TypeScript is case sensitive, so ensure everything has the appropriate case. If there doesn't appear to be anything wrong with the code, check my blog post as described in the first course module. Here's the link. I'll add common sample application problems and their solutions to this post. Note that I don't get notified if you post comments on my blog, so consider posting comments elsewhere, as described next. If there's nothing on my blog that solves your issue, post a comment on the discussion page for the course. Here's the link. I normally get notified of every post to the discussion page. Plus, other Pluralsight subscribers will see your post and can respond. Following these steps should get you back on the path to success with Angular. In this module, we detailed what a component was and how to build one by creating a component class, defining the metadata, and importing what we need. And we discovered how to bootstrap the component we built to bring our application to life. Here again is our application architecture. In this module, we built the app component and have the very basics of our application working. Next up, let's take a closer look at templates and how Angular can power them up with binding and directives as we start building the productless component. To build a